Alright, this first video is going to cover the first unit we covered back in August. This is called the scientific method. The scientific method, we looked at what is the difference between a dependent variable, what's the difference between a control group and an experimental group, when should you graph a bar graph or a line graph, and should you graph a line graph with experimental groups, and how can you analyze data so you can form a conclusion using the scientific method. The first step of the scientific method is observations. And that just means to see or observe your surroundings. The next step is asking a question about your observation. And your question should be something that is testable and it should help you make your hypothesis. Your hypothesis is an if-then statement that has to include independent and dependent variables. Once you form a hypothesis, you can start planning out your experiment, and your experiment will test your hypothesis. After your experiment, you should be collecting data, and you're going to conduct an analysis of that data. So you're going to make a graph, either a bar graph or a line graph, and use this to compare and contrast data. Once you have done your analysis, you are ready to form your conclusion, which means you can decide if your hypothesis was right or wrong. And once you know if you're right or wrong, you're ready for the last step. That's communication. You're sharing the results of your experiment with other people. So we ran through a couple practice scenarios in our notes. You should be expecting to be able to do this on the test. So you read through. You can circle or underline the most important information. A coach wants to know if having shorter grass on the soccer fields will help his team run faster. I would say having shorter grass and running faster would be two important pieces of information. He times his players as they run the length of the field on grass that is long, medium, which is the normal, and the short. So remember that the independent variable is what you change, and the coach is going to change the grass length. And what he would be measuring here, the dependent variable, is how fast the players run. So I'm going to say speed of runners. The control group is going to be either the normal or the group that has no change. And in this case, you have a normal, that would be the medium grass length. The experimental groups, you would have two. You have long grass and short grass. Constants are things that should stay the same to help your experiment be more reliable. I would say you should probably be testing the same players every day. Make sure that you have the same type of grass. Have players run the same distance. You could have a lot more constants than that. Those are just a couple examples. And then we're going to make our graph. So the first thing we're going to do is looking at the table, we're going to figure out if we should be making a bar graph or a line graph. And some hints for you. If you only have one set of data, like one column with numbers, that would mean that that would be a bar graph. If you have time would tell you should have a line graph. So this one, we don't have time. There's one column of numbers. We're going to make a bar graph. And before we do that, we're going to write our question. So remember, I like to start my question with will. I'm going to say, and I need both my variables. Will short grass help players run faster? Make sure you end that with a question mark. My hypothesis must start with an if. If grass is short, then players will run faster. Then I'm going to set up my graph. The first thing I'm going to do is pick my labels. On the bottom, I need my independent variable. That was grass length. And on the side, I need my dependent variable. That's runner speed. That was in meters per second. And then I need to set up all of my labels for short, medium, and long. So I'm going to start with short. I'm going to use medium. And long. And then you can look at your numbers from the other section. So the fastest speed was 3 meters per second. I'm going to figure out what I should be counting by, or maybe if I should skip lines. Remember, your number on the bottom always has to be 0. So I'm going to start with 0. I'm going to count by 3s. I'm going to skip. I'm going to go 1, 2, and 3. Right now I'm also still missing my title. It should be dependent variable versus independent. So I'm going to say runner speed versus grass length. And then I'm going to graph my data. So the information I'm graphing is on that data table on the last page. So the first one, for short grass, the players ran an average speed of 3 meters per second. So I'm going to start at short. I'm going to go up until I hit 3, right there, and come back down. Okay, for medium grass, they only ran 2 meters per second. And long, they only ran 1 meter per second. My conclusion, so I'm going to look back at my hypothesis, says if grass is short, then players will run faster. Players clearly ran the fastest on the shortest grass since they ran 3 meters per second. So I'm going to say yes, my hypothesis was right. Alright, we're going to do the same thing as the last one. Pick out the most important information, figure out all of our pieces of the scientific method. A teacher wants to know if a student's test grades will increase the longer students are in school. The teacher tracks a class's average percentage from August to May. The teacher thinks that student test grades will be highest in May. So my independent variable is what I'm changing. You can either think, am I changing the time that they've been in school, or am I changing the test grade? And you don't have control over people's test grades, so I would say time in school. The dependent variable is their test grade, it's what you're measuring. I'm also going to include my unit, that was a percentage. The control group is either the normal or the group with nothing. So in this case, you're comparing this to that first test they would ever take. That would be in August, when you haven't taught them anything. You walked into class and your teacher gave you a test on the very first day. The experimental groups would then be anywhere from September through May. And constants are things that stay the same between your experiment, so you want things that should keep your results a little bit more reliable. I would say that your test should be the same every single month. The students should be the same every single month. Maybe even the teacher, the class, the time of the month you give it to them. Maybe you want to give it on the first day of the month, the last day of the month. Those can make a big difference. Okay, the first thing I'm going to do is come up with my question. I'm going to say, will students' test grades be higher the longer they are in school? Okay. My hypothesis has to start with if, so I'm going to say if students are in school longer, then their test scores will be higher. I'm going to set up my graph. On the bottom, I'm going to have my independent variable. That was time in months in school. On the other side, I'm going to have their test grade in percentage. I'm going to set up my numbers here. So for time in school in months, I have August through May. To make this a little bit simpler, I'm just going to put the first letter of each month. So A for August, S for September, and so on. And for test grades, you can look at the chart on the last page. The biggest number we had for test grades was an 82%. So I'm trying to get 82 as close to the top as I can. Remember that the number 0 is going to start at the bottom. And then I'm going to count by tens. Okay, and I'm still missing my title. I need my dependent versus independent, so I'm going to say test grade versus time in school. Then I'm going to graph my data. So I'm using the information from the page before this. In August, it looks like the average test percent was a 60%. So we're going to find August, go up, here's 60. September was 65, then 68, then 70, then 73, 80, back down to 70, then 55, 60, and 82. And then we need to go back and we need to connect our dots. And we have our line graph. So now we're going to work on our conclusion. So when you do your conclusion, look back at your hypothesis. The hypothesis says if students are in school longer, then their test scores will be higher. So the highest test score was in May. You had an average of 82%, which is actually higher than in December, and 80%. We're going to say, yes, my hypothesis was right, but you did see some things that you weren't expecting. So I can say, however, in February, March, and April, test scores decreased. In the next one, we're saying a scientist wants to know how fast 3 different types of trees grow. I'm going to highlight how fast they're growing and the different types of trees. She decides to measure the height of young oak, maple, and cherry trees. The scientist thinks that maple trees grow the fastest of all the trees. They measure the height of the trees for 6 weeks. So you have to think, the independent variable, what I change? Are you changing how fast the trees grow or the types of trees? You're changing the tree type. For the dependent variable, you are going to be measuring their height of the tree. The control group is either the normal group or the one that has not received the change. So in this one, it looks like the scientist is trying to compare to maple trees. We're going to say maple trees should be the control group. I'm going to pick the other two. We have oak and cherry as our experimental groups. That's what we're comparing. And our constants, some things that stay the same. I would hope that they're all trees instead of just vegetables or fruit. They're all trees. You could also say the amount of sun, maybe the amount of water, the soil, the temperature should all stay the same. Those are things that could impact how fast a tree is growing. And then we're going to work on making our graph. First thing I'm going to do is ask my question, will maple trees grow faster? Oops. grow faster than cherry and oak trees. My hypothesis would be if we plant maple trees, then they will grow faster. I'm going to set up my graph here. So on the bottom, I'm going to have what was in the first column on our table. That was time in weeks. And then what we're measuring here is the height. I'm going to say tree height. And it looks like we're measuring that in inches. I'm going to set up my title. I'm going to say tree height versus time. And then I'm going to set up my numbers. So on the bottom, make sure you always start with a 0 in the corner. Okay, it looks like for time in weeks, we went up to 6 weeks. And if you look for the biggest number in height, it goes up to 12, and you want to count up to as close to 12 as you possibly can. You could count by 2s, it's not going to quite get you with 12 up next to the top. I'm going to count by 1.2. Alright, now that I have my number set up, I'm ready to make my graph. The first thing I'm going to do is make my key. So I'm going to pick some colors here. I need one for oak, maple, and cherry. I'm going to pick brown for oak, I'm going to pick green for maple, and I'm going to pick red for cherry. And I would always start with the first column. So in your graph, you have oak tree height in inches at 0. In time, it was 0 inches, so I'm going to put a dot right above 0, 0. At 1 week, it was 1 inch tall. At 2 weeks, it was 3 inches tall. And then it goes 4. And then 5, 6, and 7. And then I need to go back and connect my lines here. And the next one I'm going to do is graph maple. And maple starts off at 0 again, so I'm going to put a dot right on top. And then when time was 1, height was 2. When time was 2, height was 4. And then it goes to 6 and 8, 10, and 12. I'm going to connect my lines. And then the last one I have is cherry. Cherry starts off at 0, 0 again, and then it's at 1.5. And then it's at 2, and 2.5, 3, 3.5, and 4. I'm going to connect my lines here. And I'm all finished with my graph. I'm going to go back, write my conclusion. So if you look at which tree grew the tallest in the shortest amount of time, that would be your maple tree. So I would say my hypothesis is right because maple trees grew the fastest. One of the last pieces we covered in this chapter was the difference between a hypothesis, a theory, and a law. A hypothesis is what we were working on the last couple pages. It's an if-then statement. Has never been proven wrong would be a theory. Could be right or wrong, I would say a hypothesis. You could also argue that it could be a theory because a theory has never been proven wrong, but it doesn't mean that it will never be wrong. The one that is supported by math would be a law, has been tested many times, would be a hypothesis, and a theory and a law. Is a fact that can never be wrong is only a law. And that is everything for our scientific method unit.